Hello again. Here's an updated video of the completed 1802 MCP or 1802 membership card programmer. And this is the programmer. It's an Arduino-based microcontroller device to upload information up to the 1802 membership card, which is a Cosmac Elf clone type computer, which uses data switches as an input. So here's the device. Previously, I just uploaded a video of the prototype. Here's the completed device. It's on a single circuit board. And as you can see, it's got a 128 by 128 color LCD. There's an SD card you can see right there hiding underneath. Micro SD, sorry. And here are the buttons, the input buttons, right here. Reset button, here's the shift register, and I should get a pen, hold on a minute. And there's the microcontroller, here's the shift register, reset button, power light, directional control buttons, active matrix display. Here's a switch for the power, and here's a switch to put the 1802 membership card in suspend. It basically controls the grounding of the suspend pin on the 1802 membership card. It's powered by a USB, micro USB, and it actually feeds power to the 1802 membership card. I'll flip it over and then you can see what it's like underneath. It's just hand wiring. All wires are connected to this header at the top. Not much else to see there. Okay, so let's give it a try and give you a bit of a demo. Let me turn it on. And it's sending power to the membership card. Reset it to start it. And here the screen comes up. And there's the ELF, it's running. There are a few changes to the software since the last time. I've made it to where it remembers the current clock speed of the membership card. So you don't have to keep running the speedometer, you only have to do it when you change the clock speed. The speedometer functions right here. If you run that, it uploads a blink program that blinks the LED at a specified interval. And based on this, the membership card programmer can determine how fast it's going. You can see it's updating there. Then I press it again, it stops, and then it tells you it's 1.77 megahertz. All right. So just a quick demo, since I've run through most of this with the other video. This is a list of the SD card. Let's upload a program. This is the Arecibo program in binary. You can view it. So we'll view it real quick, make sure it looks okay. All right, looks good. Then I'll upload it. It uploads. After each upload, it verifies automatically. It says it was verified okay. And then what I'll do is I'll put it in run state. So right now I'm selected on the state line. If I press select, it'll put it in run. And then you can see the LED is flashing the Arecibo message. All right. Press the select button again and it will put it back in suspend, and you can see the program has stopped. It's suspended with the LED on, which is just random. Memory state you can change to write or read. You can view the RAM, and this basically shows you current memory locations. Starting with address 0, if I push the right button, then it takes me up a page, and you keep pressing the right button over here, and basically it takes you through the memory. All right, so memory on this device was really tight, getting all this logic in, but I managed to move some code around to where I could add a modify RAM feature, which is right here. And what this does is allows you to go into the memory and modify the memory locations directly using the MCP. So right now, what I have, to demonstrate this, let me upload the blink program. So here's the blink binary program. Let's view it just real quick. So basically the key part is the second memory location at address 1 is 29. That's the blink delay. So what I'm going to do is I'm going to load this, upload this, and it's verified, okay. And if I run it, you can see the blink is flashing at about once, I think once a second. Maybe a bit quicker than a second, but each time it comes on is 1 second. All right, so I'll stop it. Now I'm going to go in and demonstrate the modify RAM. I'm going to modify that memory location to a different number so it flashes at a different rate. So address, I'm going to select, and then you can actually go to each bit you want to change. And I'm going to change it to bit address 1. That's the location we wanted to change. I hit enter. It immediately updates the value, tells you value is currently 29. Oops, sorry, I pressed it twice. And then I'm going to change it to new. The new byte I'm going to change to, I'll make it really quick. I'll make it like, change it to 08. All right. So then when I change it, what it's going to do is it's going to change that memory location and then advance the address to address 2. So you can actually update a series of memory locations without too much bother. So update, okay, it already did the update. It's advanced to 2, which it tells me is B2, which is fine. I don't want to change that. And then what I'll do is I'll look at the memory, make sure it changed it. You see F8 and then 08, which is what I put in there. So then let's go back and check it, put it in run state. You see it's flashing much quicker now. All right. So that's a demonstration of that. The other features are the same. The download RAM, you can download, any size up to 64K. You can download it in any format, hex or binary. And then when you want to begin, that's that. And let's just download it. So right now it's sending the signals to the ELF. It tells you it's saved to the RAM to MCP 0007 bin. So let's go to the SD, see if we can see that. I'm going to go off the top because you can page down right there, and I'm going to go through the pages. MCP 0007, that's what we're looking for. There it is. And it's 24,576 bytes. If I select that, I can view it. And it's got all the memory in there. Right? And the F8, the 08, it's the same. That's the program that was in there last. You can upload to different offsets. I've did it offset to different pages of memory, since that makes the most sense generally. Let's see, anything else? Everything else I've pretty much showed you. You can disconnect the ELF. When you disconnect it, the ELF it's basically disconnected manually. It dims the screen as well. Basically, the ELF now works as if there was nothing attached to it. So, useful feature. You can then reset the MCP. It goes back into control and it halts the ELF. Just as a precaution, you can view the RAM. All right, and it's still in there. All right. Okay, and then, so that's pretty much it. I hope you've enjoyed the video and hope you found this interesting. All right, thanks a lot. Bye-bye.